There is a Carnot engine whose efficiency is 50%. So efficiency we'll write it as eta, which is equal to 50%. And it has a source temperature. Let's consider source temperature as T1, 600 Kelvin. And now what are they doing? The efficiency they are increasing from 50 to 70%. So let's consider new efficiency is eta dash, which is 70%. So now they are keeping the temperature of the sink constant. Let's consider T2 is the temperature of the sink, which is constant. So in order to increase the efficiency to 70%, how much the source temperature should be increased? So T1 dash we need to find. So let's consider this is the source. Now the engine will do some work and it will give the remaining energy to the sink. So this is how the engine work representation can be done. In this process, the efficiency is nothing but output by input. Here output is this W, input is this input energy from the source. So in terms of temperature, we can write it as T1 minus T2 divided by T1. But T1 is the temperature of the source, T2 is the temperature of the sink. So let's consider the first case. Here eta equal to 50% and T1 equal to 600 Kelvin. So using this, let's find T2. So eta is T1 minus T2 by T1, which is equal to 600 minus T2 by 600. So eta 50%, which can be written as 5 by 2. So 600 minus 2 by 600, we'll get 300 equal to 600 minus T2. So T2 equal to 300 Kelvin. Yeah. Now let's go to the second case where the efficiency is 80%, sorry 70%, and the temperature of the sink is same. Now 70% and T2 remains same, so this one, and T1 we need to find. So let's substitute. 7 by 10 will become T1 minus 300 divided by T1. So 7 T1 equal to 10 T1 minus 3000. So 3 T1 equal to 3000. T1 equal to 1000 Kelvin. So the new temperature of the source should be 1000 Kelvin. Option 2 is the correct answer.